Application example. We will use the following example application to clearly demonstrate how to wire and configure an SR-760. In this example, we have a radial system and will set up a common distribution protection scheme known as a fuse saving strategy, which uses an auto-reclose function only found in the SR-760. The auto-reclose function removes power from the feeder for a brief period of time by cycling the breaker open and closed. This subject is covered in more detail within the Fundamentals of Modern Protective Relaying Learning CD. The maximum load current is 300 amps, and the recommended fuse is rated at 400 amps. The results of the coordination study are as shown in this diagram. The protection engineer chose the extremely inverse time over current curve with a time multiplier of 1 because it coordinated best with the fuse clearing curve. A value of 1200 amps or 3 times the fuse rating was chosen as the pickup level for the time over current element. High and low set phase instantaneous overcurrent settings. The objective of a fuse-saving protection scheme is to set up the protection such that a transient fault will not cause fuse damage or result in a field visit, and is accomplished as follows. One of the instantaneous overcurrent elements will be called the low-set instantaneous overcurrent element because its pickup will be set such that its operate characteristic will intersect the fuse curve as shown. In our example, a pickup of 1.6 kiloamps. This element's operation will initiate auto-reclosure and will trigger an internal signal to block its operation upon reclosure. The operate characteristic for the first fault will look like this. The high-set instantaneous overcurrent will be set to a typical pickup of 6 times the maximum load current, or 1.8 kiloamps in our example, with a delay of 2 cycles coordinated with the low-set instantaneous overcurrent. If we reclosed into a fault, the low-set instantaneous overcurrent is temporarily disabled, and so the high-set instantaneous overcurrent will clear high-level faults while the fuse backed up by the relay's time overcurrent element will operate for lower-level faults. This scheme is referred to as a fuse-saving protection strategy because a transient fault will trigger the operation of the low-set instantaneous overcurrent, which will temporarily remove power from the faulted feeder and hopefully save the fuse from blowing. The ground instantaneous overcurrent element will be set to half of the load current, or 150 amps. Now that we understand the scheme, the wiring diagrams will provide the additional information for the relay's configuration. The phase and ground CT's primary is 500 amps, while the secondary is 5 amps. The feeder voltage is 4,160 volts, and the PT ratio is equal to 35:1. The ground CT is wired in the zero sequence configuration. The VTs are wired in a Y configuration. Logic input 1 is wired to the breaker's 52A contact, while logic input 2 is wired to a 52B contact. Both the trip and close outputs are wired. This section will provide an example of programming a relay using the EnerVista 750-760 setup program. The first step in using the setup program is to configure the communications to allow us to talk to the relay. We will do this by selecting the Device Setup button located above the online window on the left side of the screen. In the window that appears, you will see the panel on the left-hand side showing the text, "Please add a site." This indicates that no sites or devices have been set up for communications. First, we need to add the site that will contain the relay. Press the Add Site button found at the top of the window. A new site will be added with the default name, New Site 1. To change the name of the site, click on the Site Name field and type in a new name. For our example, we will type in Feeder 123. Next, we will add all of the devices that we want to be found in that site. Highlight our site by clicking on it and press the Add Device button. Two things should now have occurred. The name of our site would have changed to Feeder 123, and a new device will be added to the site with a default name, New Device 1. We now need to configure that newly created device. In the panel on the right, click on the Device Name field. Type in a new name that describes that relay. Open the pull-down menu. Because we are configuring to communicate with an RS-232 serial cable, we will select Serial from the menu. Several new fields will appear in the area below. The Modbus slave address is used to identify specific devices for communicating on the network. When communicating through the front port, there is only one device on the network. Therefore, there is no risk of communicating with the wrong device. For this reason, we can leave the Modbus slave address to the default of 1. In the COM port field, select the communication port of your computer that the serial cable is connected to. The COM port that we are using is COM1. Therefore, we will leave this at the default. The baud rate is user programmable. In this example, we will set it to 19,200. The order code and firmware version of your UR can be read from the relay itself to fill in the last two fields. Press the Read Order Code button. Press the OK button. Basic Setup. The following section will provide simple instructions for using the EnerVista 750-760 setup program to configure the 750 relay. Once the device setup has been completed, you will see the name of the site you have created in the device window. By opening this menu, you will see the name of the device that was set up for communications. Opening this menu further, you will see the menu structure for the relay itself. This is one of two methods that can be used to view the settings and actual values that are present in the relay. By double-clicking on the settings and then the relay setup, you will see the available settings for the basic operations of the relay. By double-clicking on a settings menu, you will see the specific settings for that function. For example, by double-clicking on passcode, you will be able to see the settings for enabling and disabling the passcode protection. The second method for viewing the settings in the relay is to click on the Setpoints drop-down menu located at the top of the EnerVista 750-760 setup window. This will show a list of all settings pages within the relay. Please note that the grouping under the Setpoint drop-down menu matches the structure of the Setpoint pages found in the relay. If you familiarize yourself with the menu structure by using the PC program or the keypad, the transition to the other interface will be very simple. Double-click on Relay Setup. A window will open that displays all submenus, including passcode. Clicking on the Passcode tab allows you to view the settings for enabling and disabling the software security. Customizing the appearance of the setup program can make it easier to navigate the settings of the relay. For instance, the settings windows can be resized. For this training CD, we will be using the drop-down menus located at the top of the window, so we can close or shrink the file and device windows to allow a larger viewing area for the settings. Double-clicking on the border of the settings window will size it to the available viewing area. We will now program the basic relay set points required to protect a feeder. The values we will be using are intended only as an example. Let's start by entering some of the basic settings required for the 750 relay to operate properly. The first is the passcode. This setting, in combination with the hardware setpoint access switch mentioned earlier, provides security for the relay and its settings. Click on the Relay Setup menu and then the Passcode tab. Setpoint access will let you know if the relay allows setpoints to be written to the device. If the access states Read Only, then the device has been passcode protected. All relays are defaulted from the factory with no passcode protection. To enable the passcode protection, click on the Change Passcode button and enter your passcode twice. You can now select the Restrict Access button. If you forget your passcode, there is an encrypted passcode provided. Please record this encrypted passcode and call GE Multilin Technical Support for assistance. If you wish to disable the passcode protection, simply change the passcode to 0. This will remove any passcode protection from the relay. One of the advantages of the SR-750 relay is its ability to record events that occur within the system or the relay itself. It is recommended to ensure that the event recorder is programmed to record the events that are important to your application. By selecting the Event Recorder tab, you can program what internal flags in the relay will record an event. Simply disable any event types that you do not wish to be recorded. For example, if you are using a PLC to broadcast the date and time to the relay regularly, you may wish to disable this in the event recorder. This will prevent the event recorder from being filled with time and date setting events. When you have changed a setting in the PC program, the new setting does not take effect until it has been saved to the relay. Always click on the Save button after making the necessary changes to the settings. To ensure that the recorded events and waveform files are time and date stamped correctly, select the Real-Time Clock tab to set the date and time. You can choose to synchronize the relay date and time to your computer using the Sync Relay to Computer button, or you can store the date and time manually by entering the information and selecting the Set Manual Date and Time button. If more accurate timestamping is important to your application, it is possible to connect the SR-750 to an iRig-B generator. You must select the iRig-B type as either DC shift or amplitude modulation. If you have a relay that has the factory default settings, you will see that there is a self-test warning present on the display indicating that the relay is not ready. To prevent the relay from being installed into a system with the default settings, there is an installation setting that must be programmed in order to enable the protection and control elements of the relay. Select the Installation tab and change the SR-750-760 operation setting to Ready. System Setup. In order to properly protect and meter measured quantities, the relay must know the specifics of the power system and how it is connected to it. The following section will demonstrate how to configure the relay to accurately measure the magnitude of current and voltage quantities. From the Setpoints menu, select System Setup. Under the Sensing tab, you will find the settings for the current and voltage transformers. For our application, the phase and ground CT primary should be set to 500 amps. If the sensitive ground input were being used, the CT primary rating would be entered into the area indicated. If wired, the voltage transformer, or VT configuration, must also be configured. As discussed earlier, there are two separate VT connections, the three-phase bus connection and the single-phase line VT. In our application, only the bus VTs are required to be configured. The VTs are wired in a Y configuration, and so the Y connection is selected. The bus VT nominal secondary voltage will be the nominal phase-to-phase system voltage divided by the VT ratio and then by the root of 3. The VTs must be selected so that the secondary voltage falls between 50 and 240 volts. Our application does not use a line VT, but if it were used, the line VT can be programmed as either a Y or delta connection. Make sure you confirm the location of the CT installation prior to setting this parameter. The secondary nominal voltage and VT ratio can then be programmed using the same procedure as was done for the bus VTs. The nominal system frequency and phase sequence should also be programmed. Logic inputs. This section will demonstrate how to set up the logic inputs that allow proper detection of the breaker status. In order to detect the condition of the breaker, the relay needs to be connected to the 52A and 52B auxiliary contacts of the breaker. The relay uses logic inputs to detect the changes in the breaker auxiliary contacts. The first step is to program the names and asserted logic of the inputs. To do this, we will select the Logic Input Setup from the Logic Input menu. We will be using Logic Input 1 as the breaker 52A auxiliary contact and Logic Input 2 as the breaker 52B auxiliary contact. Enter their names and make sure that both contacts are programmed and asserted contact closed. Save these changes to the relay. We must now program the relay to recognize these contact inputs as the 52A and 52B contacts. The set points for the 52A and B contacts can be found under Breaker Functions in the Logic Inputs menu. By selecting the parameter, you can assign a logic input to each function. As discussed, Logic Input 1 will be assigned to the 52A contact, and Logic Input 2 will be assigned to the 52B. This will allow the 750 relay to sense when the breaker is open and closed, and allows breaker failure protection to be enabled. There are many functions that the logic inputs can perform, such as remote trips, resets, initiating a waveform capture, or blocking protection elements. The same procedure for programming the breaker auxiliary contact should be followed for any logic input. For example, if you want to use Logic Input 3 as a remote trip, simply open the Logic Input Setup and program the name of Logic Input 3 as Remote Trip. Next, select the control functions from the Logic Input menu and assign the remote open as Logic Input 3. Output contacts. In this section, we will take a look at the output contacts available with the 750 relay. The SR-750 relay has a total of 8 output contacts. 3 of the output contacts are programmed to be the trip, close, and self-test contacts and cannot be assigned to any other function. The remaining 5 relays are designated as auxiliary contacts and can be assigned to different functions within the relay. The set points for the functionality of the output contacts are located in the Output Relays page of the Setpoint menu. You will see that there are tabs available for the trip, close, and auxiliary relays. The trip and close relays are automatically assigned to any element of the relay that controls tripping and closing of the breaker. They are designed to be non-fail-safe contacts, and their operation or functionality cannot be changed. As you can see by clicking on the trip and close contacts, the only setting that is available is the seal-in time of the contact. A seal-in time of 0.04 seconds for both the trip and close is appropriate for the breaker used in our application. The auxiliary contacts can be programmed to operate under the set points for the protection, monitoring, and control elements of the relay. They can be used for a number of different applications and therefore have more flexibility in their programming than the trip and close relays. As an example, we will be using auxiliary 7 as an alarm relay. The first step is to program the name of the relay to alarm. We must then set the non-operated state of the relay. A non-operate state of de-energized means that the relay's normally open contacts will remain open until there is an alarm condition. This is considered non-fail-safe operation. A non-operated state of energized indicates that the relay's normally open contacts will close when power is applied to the relay and will open when there is an alarm condition. This is considered fail-safe operation. We will leave the setting as de-energized. The output type can be programmed as self-reset, latched, or pulsed. We will change the setting to latched. This means that the output relay will not return to its de-energized state until a reset command has been issued to the relay, whether via communications or using the reset button on the front of the relay. Self-resetting will allow the output contact to return to its de-energized state as soon as the signal causing it to operate is removed. To set the high and low set phase instantaneous overcurrent settings, go to the Protection menu and then the Phase Current submenu. Phase Instantaneous Overcurrent 1 will be the low set instantaneous overcurrent element. Its pickup will be set to 1.6 kiloamps, or 3.2 times the CT primary rating, and it will be configured to close the trip relay and trigger the auto-reclose as shown. Phase Instantaneous Overcurrent 2 will be the high set instantaneous overcurrent element. Its pickup will be set to 1.8 kiloamps, or 3.6 times the CT primary rating, with a delay of 0.04 seconds to coordinate correctly with the low set phase instantaneous overcurrent. It will also be configured to close the trip relay. The time overcurrent element configuration. Phase time overcurrent 1 will be configured to use the extremely inverse time overcurrent curve with a time multiplier of 1 and a pickup of 1200, or 2.4 times the CT primary ratio. Save these settings. The last step is to configure the auto-recloser function as follows. From the Set Points menu, select Controls and then Auto-Recloser from the submenu. Set the auto-reclose function to Enabled and the maximum number of shots to 1. The auto-recloser reset time and incomplete sequence time would also normally be set, but for the class example, the defaults will be fine. Save these settings and then proceed to the Reclose 1 menu. In the Reclose 1 menu, the protection engineer would program in the dead time, or the time the breaker will remain open. This timer starts when the relay receives a signal from the 52B contact input indicating that the breaker is open. For our application, Reclose 1 is also configured to block the phase instantaneous overcurrent 1. Once these settings have been saved, the relay's configuration is complete. Now that we have programmed the basic set points that the relay needs to monitor the system, let's take a minute to look at where the relay displays the metered and calculated values from the system. Select the Actual drop-down. The subheadings in this menu contain all metered values in the system, the current status of control elements, such as the auto-recloser, as well as historical data, such as the event recorder and oscillography files. To view the status of the hardware inputs that we have programmed, select A1 Status from the Actual menu. The Status subheading contains tabs for the current status of relay control elements, virtual and hardware inputs, as well as the date and time information. By selecting the hardware inputs, we can check the status of the 52A, 52B, and remote trip inputs that we programmed. All three contacts are currently open or non-asserted. Any metered or calculated values from the relay can be found under the A2 Metering subheading. There are tabs available for displaying real-time currents, voltages and frequency, as well as the calculated power, energy, and demand values. The metered analog input values will also be available here if they've been programmed. The A3 Maintenance heading provides historical data that will assist in planned maintenance of the breaker. A complete history of all trips is available, as well as measured arcing currents. One of the strongest tools available with this relay is its event recorder. As we saw when programming settings for basic relay operation, the event recorder can be programmed to record any trip, control, or alarm events. The event recorder can store up to 128 events. If the number of events exceeds 128, the oldest events will be replaced with new events. This information is non-volatile and will not be lost if the power to the relay is removed. Let's take a closer look at how to access the event information. Select the event recorder from the Actual drop-down menu. At the top of the event window, you will see a list of all events that have occurred in the relay. This list will include the time, date, and cause of the event. If you scroll down, you will see a drop-down bar for selecting the specific event number you wish to look at. We will choose event number 1, listed above as Clear Event Record. Scroll further down the page. Now we can see the metered information from when the event occurred. This is a snapshot of the exact values seen by the relay when the clear event occurred. There are two buttons on the right side of the screen. The Clear Events button will reset the event recorder, deleting all event data from the relay. We will select the Save Event Data so that we can store a soft copy of the events for future analysis. You will be prompted to save either all of the events in the event record or only the events that have been selected. We will choose All. It is important when naming the event file that the extension remains as CSV. This will allow the events to be opened in Microsoft Excel. You now have a permanent copy of the events and can reset or clear the events in the relay. We will do this by simply selecting the Clear Events button. When the clear is complete, you will only see a single clear events listed in the event recorder. A5 product information will provide hardware and software information specific to this relay. This information includes serial number, firmware or software revision, and the order code of the relay. There is also a calibration tab that will record the most recent date the relay was factory calibrated. The waveform capture is an invaluable troubleshooting tool provided with the relay. It will capture an oscillography file whenever a system event is recorded by the relay. These waveforms show the current, voltage, and digital waveforms for before, during, and after the trip. The waveforms are stored in volatile memory, so any loss of control power will cause the information to be lost. Waveforms should be stored prior to removing the relay from the system for maintenance. To access the waveform capture, select Waveform Capture from the Actual drop-down menu. In this window, you will see the total number of waveform captures that are currently stored in the relay, as well as a drop-down tab for selecting which waveform you wish to view. There are also buttons available to manually trigger a waveform, to clear or erase the waveforms, to save the waveforms to a file, or to open a waveform that was previously saved. As we currently do not have any waveforms present in our relay, we will select the Trigger Waveform button. You will see the total triggers increase to 1. The select trigger will remain at 0 as the numbering of the waveform starts at 0. To the right of the Trigger Waveform button, you will see a button for launching the viewer. Click this button to view the selected waveform. When the viewer opens, you will see the waveforms displayed in the bottom right-hand window. This window operates very much like an oscilloscope. There are two cursors, colored blue and green, that can be moved horizontally along the waveforms. The window to the left of the waveform will display the metered values at the position of the cursors. You can select to view either or both of the cursors, as well as the delta value between them by selecting any combination of the three buttons at the top of this window. The red line in the waveform window indicates the moment when the waveform was triggered. The trigger position can be changed to provide more or less pre-trip data. This setting can be adjusted as follows. Select Setpoints, Relay Setup, and then the Trace Memory tab. The trigger position is currently set to 25%, indicating that 25% of the waveform will be pre-trip data and 75% will be post-trip data. If you wish to have more of the pre-trip information captured, simply increase this value to the desired level. You can also program what relay events or flags will trigger the waveform capture. We will program it to capture a waveform when a trip event occurs by changing the trigger on trip setting to active. The data logger is similar to the waveform capture, providing historical system information. The difference is that the data logger can be programmed to capture only the analog values that are required. Data will be captured at time intervals determined by user-programmable setpoints. The captured information is stored in volatile memory and will be lost if control power is removed from the relay. Select Active Conditions from the Actual menu. This will display any protection elements, alarms, or control elements that are currently operating in the relay. Settings files are a convenient way to store and edit offline settings for relays. Files can either be created using the EnerVista setup program, or settings already existing in a relay can be downloaded into a file. These settings can then be edited or simply uploaded back into a relay. To create a new settings file, select New Settings File from the File drop-down menu located at the top of the screen. This will open a window that will ask you to select a name for the file as well as a location to store it. You will also be asked to set the properties of the file. Select the button containing 3 dots to choose the name and location of the file. Enter a file name of Default and save the file. You must now decide if this setting file will be used for an SR-750 or SR-760 relay. You will also be asked to select if the relay has a sensitive or polarizing ground CT. Finally, the firmware revision of the file must be entered. The properties of the settings file will generally be entered to match the properties of the relay that the file is intended for. If any of this information is unknown, the properties of the file can be edited later prior to downloading the file to the relay. We'll discuss this in a couple of minutes. Once the settings have been entered for the file, select OK. You will now see the name of our settings file appear in the file window on the lower left side of the screen. This setting file has been created with all of the default settings a relay would have when shipped from the factory. You can edit the settings of this file by simply selecting the file name and then using the Setpoints menu at the top of the screen to select the specific settings to be changed. Programming the settings of an offline file is performed exactly the same as when communicating to a relay. As mentioned earlier, existing settings can also be saved from a relay. To do this, establish communications with the relay by selecting the relay name and then choose Read Settings from Device from the File drop-down menu. Once the setup program has read the device settings, you will be prompted to enter a file name. Enter the relay name and select Save. You will now see this settings file located in the file window below our default file. To edit the settings of this file, select the file name and then select the settings group you wish to edit from the settings menu. The properties of each of these files can be viewed and edited by selecting the name of the file and then choosing Properties from the File menu. The properties of a file must match the relay properties in order to download the settings to the relay. Let's download the default settings file that we created to the relay. We must first check the properties of the relay. To do this, we establish communications with the relay and then select Product Info from the Actual menu located at the top of the screen. We can see from the order code that this is a 760 relay. The S5 indicates that a sensitive ground CT has been installed. The software or firmware revision is 5.01. This is all the information we will need. We next need to compare the properties of our relay to those of the default settings file. Select the file name and then choose the properties from the file menu. We can see that the file was created for a 750 relay and the firmware is revision 3.0x. We will need to change these settings to 760 and 5.0x in order to download the file. Make the necessary changes and then select Convert. To send the settings file to the relay, select the file name and then choose the Write Settings to Device option under the File menu. You will be prompted to select which device you wish to download the settings to. Highlight the name of our relay and select Send. The default settings will now be downloaded to the relay. Please note that settings files should never be downloaded to the relay if it is in service. Protection elements will not be able to function while the file is being programmed. In addition to the primary protection elements of the relay, this relay also offers a number of functions that allow monitoring of system conditions and equipment. These elements are found under Setpoints, Monitoring. We are now going to program the coil monitor protection for the trip and close coils. Access these settings by selecting Equipment. Select the Coil Monitor 1 to program the trip coil protection. The name of the coil monitor will be programmed as Trip Coil. As with the breaker failure protection, this element cannot be assigned to the trip contact, as it indicates a failure in the trip circuitry. For our application, we will use it to operate an alarm. Select the function as Latched Alarm. Relay 7 must be enabled, as it is our alarm relay. If the breaker state bypass is disabled, the coil monitor will only operate when the breaker is closed. If enabled, the coil circuitry will be monitored regardless of the state of the breaker. In order for this element to be enabled, trickle resistors must be installed around the 52 contacts of the breakers. We will enable this function for our application. The coil monitor type is used to tell the relay if the coil monitor 1 is wired to the trip or close coil. As we have assigned the name of this monitor as Trip Coil, we will leave this set point as Trip. Select Coil Monitor 2 to program the close coil protection. Program the name and coil monitor type to Close Coil. The function will again be assigned as Latched Alarm, and the alarm relay 7 will be programmed to operate. Breaker state bypass will be enabled. The relay is now programmed to monitor the trip and close coils of the breaker. Any break in the continuity of the trip or close coil circuitry will cause the coil monitor alarm to operate. There are 4 settings groups available in this relay. In some applications, changing loads or environmental conditions may require a change in the protection settings. The different settings groups allow 4 sets of protection elements to be programmed without changing any of the system or relay settings. Logic inputs can be used to automatically switch from one settings group to another. We will first assign a logic input to change from settings group 1 to settings group 2. Select Settings, Logic Inputs, Logic Input Setup. We will name Logic Input 5 as Setpoint Group 2. Now we will assign Logic Input 5 to change the active settings to Group 2. Select Settings, Logic Inputs, Control Function. Change the Setpoint Group 2 setting to Input 5. The relay will now switch the protection settings from Group 1 to Group 2 when Logic Input 5 is asserted. When the relay is using the Group 2 settings, the Setpoint Group 2 LED on the front of the relay will be illuminated. In order to program the settings for Setpoint Group 2, we must tell the relay that the changes we are going to make are intended for the Group 2 settings. To do this, select Control from the Setpoints menu and click on Setpoint Groups. The active Setpoint Group setting allows you to change which of the 4 settings groups is being used without asserting a logic input. This is generally left programmed as Group 1, and logic inputs are used to change the groups. The Edit Setpoint group allows you to select which setting group you wish to program. This is usually set to Active Group, but can be changed to allow programming of other groups. Change this setting to Group 2. When the Edit Setpoint group is programmed different than the Active Setpoint group, the LED for the Edit group will flash on the front of the relay, while the Active Group LED will remain solid. If we now select the Timed Overcurrent 1 protection that we have already programmed, we will see that all settings have been returned to their default values. This is because the previous programming was done in Setpoint Group 1. Any changes made at this point will only affect Setpoint Group 2. When programming of the second Setpoint group is complete, go back to the Setpoint Group settings found under Control and return the Edit Setpoint group to the Active Group setting. This will assure that the settings seen during any troubleshooting of the system match the settings that are being used to protect the system. Upgrades and firmware revisions allow enhancements in protection elements and operational performance of the relay. The EnerVista setup program has been designed to allow the firmware of the relay to be upgraded without requiring the relay to be returned to the factory. The latest revisions of firmware are always available on the GE Multilin website and can be downloaded free of charge. To upgrade the relay, simply establish communications with the relay using the setup program. Select the Communications drop-down menu at the top of the screen. Click on Update Firmware. You may be prompted to close all device windows before proceeding. Select Yes. We will now be asked to make sure that the relay is out of service. All protection elements are lost when upgrading the firmware, so this operation should never be performed on a relay that is providing protection. Select Yes to proceed. The SR-750 relay has two separate microprocessors requiring two separate files to be downloaded. When the Load Analog Board File window opens, select the folder where the firmware files have been stored. You will only see one file available for download. The second last letter in the file name will be A, indicating that this is an analog board firmware file. Select this file. You will now be asked if you wish to upload the control board firmware. Select Yes. You will again see only one file containing a C as the second last letter. This is the control board firmware file. Select this file to begin programming the firmware. A window will appear indicating that the firmware is being uploaded to the device. A status bar at the bottom of this window will inform you which board is being programmed. This window will close, and the relay will reset when the firmware upload is complete. All settings within the relay will be lost when the firmware is upgraded. It is very important to save a copy of the settings file prior to upgrading the firmware. The file can then be downloaded back into the relay when the firmware upload is complete. Additional protective elements. In this section, we will quickly review the operation and configuration of other commonly used protective elements that were not required by our example. The main voltage protection elements are the bus and line under voltage elements. This relay considers the bus voltage to be the voltage metered on the source side of the breaker, while the line voltage is metered on the load side of the breaker. Let's start by selecting set points, protection, and then voltage to view the undervoltage settings. There are 4 undervoltage elements available, 2 for bus and 2 for line. The function settings available for the bus undervoltage are trip, alarm, and control. We will program the element to trip with a pickup of 0.8 times Vt. The pickup is expressed as a multiple of the programmed nominal secondary voltage. With a nominal secondary voltage of 120 volts and a Vt ratio of 120 to 1, a setting of 0.8 times Vt will cause the undervoltage element to operate at 96 volts secondary or 11,520 volts primary. We will select a definite time curve with 1 second of program delay. The minimum operating voltage defines the amount of voltage that must be measured in the system in order to enable the undervoltage element. This protects against nuisance undervoltage trips in dead bus conditions. This setting can be changed to 0 volts if you wish the undervoltage element to operate regardless of the bus condition. We will use a setting of 0.2 times Vt. Change the phases required for operation to anyone, allowing the element to operate if any phase drops below the setting. For our system, we will also program an alarm to warn us that we are in an undervoltage condition, but have not reached the undervoltage trip level. To do this, select the Bus Undervoltage 2 tab. We will set the function to alarm and enable the operation of Output Relay 7. This is the relay that we previously programmed as our alarm relay. We will choose an operate level of 0.9 times Vt, again using the definite time curve with a delay setting of 1 second. Required phases for operation will be programmed to anyone. We will now receive an alarm output whenever the voltage drops to 90% of the nominal. Select Line Undervoltage 3 to program the line undervoltage element. We will use the same settings that were used in the bus undervoltage protection. Line undervoltage 4 will be programmed to operate as a line undervoltage alarm. The breaker failure protection is designed to detect a failure of the breaker to open after a trip has been issued by the relay. It does this by monitoring the current levels in the system after the trip contact has operated. If the relay continues to meter current after a programmed period of delay, it operates the breaker failure protection. Select Settings, Protection, and Breaker Failure. As this element is used to detect a failure in the tripping circuit, it cannot be assigned to operate the trip contact. We will use this element to send a remote trip signal to an upstream device, as well as to issue an alarm. Select the element function as Latched Alarm. The Relay 7 output will again be used for our alarm relay, and we will also program Auxiliary Relay 5 to operate as our remote trip signal, wired to the upstream protection device. The breaker failure delay needs to be set to a period of time longer than the expected operate time of the breaker. We will leave the setting at 0.1 seconds. The breaker failure current is the current level required in the system to operate this element. We will program this to a value of 0.1 times CT, or 100 amps. With these settings, a breaker failure alarm will occur, and a remote trip signal will be sent to our upstream protection if the relay meters a current of 100 amps or more 100 milliseconds after a trip command has been issued.